All right, here we are. I'm here to talk to you about my work for a client, XCL Midstream, that I've been working on this spring. We're going to take a little bit of a walk around that project and highlight some LiDAR data that they acquired, some LiDAR analytics, and how we kind of brought that in for a new workflow for them. My name is Rose Iksic, and I work for Civic Mapper, and I'm going to just go over the agenda quickly here. We're going to talk about the context, what we're talking about, geohazards, what they are, what the problem is. We'll look at the integration process, what it means to bring in this new data to the workflow, some of the considerations and the changes that resulted from that, and then we'll look quickly at the importance of using high accuracy data in this particular setting. And then we'll take a deep dive into the visualizations that were created for each step of the way. But before we do that, I'm going to take a moment to introduce myself and Civic Mapper and the principle of judoka. So I like to say it's kind of our unofficial motto. It comes from the Japanese term that was coined by Toyota's founder, judoka. So we kind of put a geographic spin on it to make it geodoka instead of judoka. But it's all about process design. So what the Toyota founder came up with in his business doings was that automation alone only gets you so far, and that really creating the best product, you need to include the human element. And so judoka is about bringing those together. And my boss will often bring up the 80-20 rule. We want to maximize utilizing AI and automation as much as possible, but we also have to bring in that understanding of the human element. And what that means, in this case, our use case is making use of the Terran LiDAR analytics product, right? So we're bringing that data in. It's new technology. That's great. There's a lot of intelligence that's built into that product. But now we have to bring it to the client so that they are able to use it and make use of it. And so that's what we do. We kind of connect with the client, make sure we understand what their goals are, who's going to be using the data, what's the environment it's in, and all of those constraints. So when you do that, what you kind of get, I like to say, is it's kind of like when you pair Jack from Esri with Ty Pennington, you kind of get Extreme Makeover Map Edition. So hopefully that's what you get from this. So geohazard, slips, and climate change. Oh my. What do these three things have in common? I'll give you a hint. It's not a yellow brick road. It's pipeline integrity. So here we have an excerpt from the Pipeline and Hazardous Materials Safety Administration. And it really paints a clear picture of the problem facing pipeline owners and operators. We have changing weather patterns due to climate change that results in increased rainfall, higher temperatures, which all in turn can impact soil stability in areas that were previously stable. Here in the picture, you see what's called circumferential cracks, basically to highlight that structural integrity issues, they start small. So this is, there's all kinds of pictures. If you Google slips and landslides, the big pictures you get aren't where the problem starts. And so that kind of speaks to the need for high accuracy, which we'll get to as I go along. All of this to say, this is the background to support the idea that, the high accuracy LiDAR data is essential in a pipeline management process. It's a regulatory solution. Many of you in this room are probably familiar with a lot of these regulations here that guide many of the activities that owner-operators are required to meet. So what's clear is that prevention is not having a program that results in prevention is not an option. Prevention is required, and to do that, you have to have the right data. So beyond regulations, though, it makes good business sense. LiDAR is no longer the expense that it used to be. It's more readily accessible. It also has it has information that meets this complex issue. So there's a lot of ways to address this problem, looking at vegetation, looking at hydrology lines. So there's a lot of pieces of information to put together, and LiDAR data kind of meets that need. Moving on to the process of integration. Okay, we've decided makes sense, LiDAR data makes sense to meet this problem, to improve our slip monitoring process. So now what do? We have our existing information, and we've got our new data integration here. You can see these two pictures kind of emblematic of the two-step process. We need to first take stock of the current system. What data do we already have? What's going on? And then where are we going? So this is a little sneak peek of one of the web apps that we created with the new data. So taking stock, we, for this particular project, the current system was an enterprise environment with point data. It's not especially mobile ready for field applications. And I don't know if this kind of environment is familiar to any of you, but in the desire to kind of move that data along to various parties, we kind of needed to break the data out of some of the limitations that were in place. This quote, I'll share it. This was in the presentation, but I read it and I was like, it's very fitting because it speaks to this process, this notion of integration. So the way to get started is to quit talking and begin doing. I like one that it's about getting your hands dirty, and it speaks to the urgency of the problem we're talking about, because rain waits for no one. But also because it speaks to that initial part of the talking had to happen. We had to come to the table. We have to understand what it is we're doing and where we're going. It needs to happen over and over again for the iterations to create a process like this and to continually improve upon it. So what did we decide to do with the caged data? Well, we kind of expanded our environment. So we have the enterprise environment, and we expanded it by adding in information data to the ArcGIS Online platform, where it can be mobile ready, field app enabled. And now that we have that expanded space for using our data, let's talk about the specific data. So the Terran data, the data set that my client got was a single data set that had a large variety of, a variety of data pieces of information. So probably 20 plus layers of information, but it was more than the client was really prepared to work with for this initial project. They received, we're moving from point data to polygon data and a variety of layers that they haven't been looking at to date. So my job was to hone in with what were the important pieces of data to focus on and visualize. So here you have the new and the old together. We didn't throw out the old. it was the baseline for understanding the pieces of information that were important in the first place, and important reference to have as well. You know, it's even with these pared down selection of data that we use from the analytics data set, it's easy to see the value here in kind of moving from the point data to what the LiDAR data offers. And here's a quick look at how the data is moving, the flow. So, and we'll look at each of these a little bit closer in the last section. But we, bring the data into Pro, move it into ArcGIS Online, where we have a field map to support field crews inspection work, and that takes us to the Survey 123 inspection form that was created to enable ongoing inspections. That information might change the status of a slip. It feeds back into the ArcGIS Online environment, which can be seen in the status app, which is shared with the appropriate personnel in the organization to help make decisions about, putting people out in the field, making repairs, what's most important at any given time. So I hope you can see we're moving closer to this goal. We've got better data on board. We're using more nimble platforms, which results in smarter, more cost-effective decision making. So we've got these things set up, and the project is ready for the field. That's my little caged bird ready to fly. Okay, so we're going to just sidestep briefly to talk about high accuracy data. We're going out in the field. High accuracy data is important. So when we're talking about geohazard management, where the millimeters of earth movement makes a difference, high accuracy is crucial. So whether you're using data that's acquired or it's in-house data collection, high accuracy is important. The data here that we use, like I said, is from Terran, and they have been amassing a content library of remotely sensed 3D spatial data from across the United States, and that's also being updated regularly. So that provides a basis of data over time that is especially meaningful in this situation. But that, together with high accuracy GPS, allows for meaningful change detection. So during the inspection process, when crews are out in the field, making note of what they see, how things are changing, and that data going back and feeding into the system, we can see, changes in a much sooner and higher rate to make better decisions. With regard to high accuracy, we worked on a data collection project for XCL earlier in the spring, and this is just a little side highlight of that. Again, we designed our field app to complement the existing data structure that lived in the enterprise environment. Crew went out, collected 1,600 valves to date this spring. And only of those 1,600, only 73 didn't meet the designated accuracy threshold, and those were, primarily all in the first day of data collection. So I like to think that I help keep things on track, but really it's about, creating a workflow in which the end user is the focus, so that they are enabled to do the best work when they get out there. So I'm confident that these successes will carry over into the slip monitoring project going forward. And so that takes us to the analysis component, the visual analysis. So we started with a PDF map book. The client requested a PDF map book, They wanted to use this to facilitate getting boots on the ground, and inspections started as soon as possible. It's kind of it's focused. It has just enough information to tell someone which slip is more pressing to visit over another. We chose to use absolute rank as a primary field to determine prioritization. And then the risk factors that are included to calculate that factor are part of the data set, and they're displayed here. And I know I was thinking earlier from one of the presentations, I definitely need to put some arcade tips to use and kind of configuring that bottom box, but perhaps in the next iteration. But you know, even though this PDF map book was intended for print, it's also web app enabled. You can see down in the bottom left, we added a dynamic field onto the layout, which holds a link that's crafted to pull up the web map and zoom into the same slip that you see here on this page. So you can be out in the field with your paper piece thing and say, you know what, this is interesting. I want to see what's like over here. How close is the next slip instance? You can easily do that and have that field reference map show up digitally. And also have a link to the inspection form as well. So again, we move from paper to web map and app. The data doesn't look all that different, of course, in the web map, but the ways that we can share it certainly are. It becomes a jumping off point for additional apps. We just saw this. I move it over. So again, map book, online presence. Let's see. Okay, and so this takes us to the status app. This was built in Experience Builder for management level to review the slip status. On the right, we have the list of slips ranked from most pressing to least pressing based on that absolute rank value. We have the information over here. You can see this initial data import brought in 67 newly identified geohazards to review. So definitely needed to prioritize what we were looking at. Let's see, I think this video is the one we built in some various filters. You can quickly look at those ranking 5 and above to simplify your map to just display, the absolutely most pressing. And maybe that's, the first week or two of doing visits, you're kind of going to focus on that, and it simplifies our list down to 34. And then this kind of just shows so what did we learn from all of this? Well, in the process, it became obvious that there's a few things that could be added to make this monitoring project even better. The first thought is enhancing the base map with some drone imagery, especially for slip areas that are deemed to be high activity areas. So that can be kind of rolled into the inspection process instead of like a larger area. And then, to bring this monitoring process full circle and to make sure it's an end-to-end solution, recommend determining inspection intervals and acquiring new data